vais commencer en français, des fois je partirai en anglais, je vais essayer de voir en fonction de vos niveaux. Et déjà, savez-vous pourquoi aujourd'hui votre enseignant vous a demandé de venir assister à ce cours en anglais? Est-ce que vous avez une idée pourquoi l'anglais et pourquoi pas que le français? Déjà.
C'est la position de langue universelle.
C'est une langue universelle, exactement. La langue des sciences. Pardon? Il y a un master exactement dans votre université en anglais. Est-ce que tous vous voulez travailler en France? Vous voulez aller travailler à l'étranger? Voilà. Et pour ça, l'anglais va vous être utile. Est-ce qu'il n'y a que des Français qui viennent travailler en France? Est-ce qu'ils parlent tous français? Alors, on peut le faire aussi en arabe si vous voulez. Mais sachez que la plupart des termes, même dans les pays du Maghreb, pour y avoir travaillé pendant 6 ans, sont essentiellement basés sur des termes techniques français. Donc c'est très bien aussi de les connaître en français. L'anglais est une langue très importante parce qu'effectivement, elle va vous permettre de communiquer partout où vous irez dans le monde et de comprendre des textes scientifiques et également d'écrire des textes scientifiques. S'il y en a certains qui veulent s'orienter vers la recherche, l'anglais est indispensable. Toutes les revues internationales, les plus grandes qui sont lues, s'écrivent en anglais. Je vais vous parler 2 minutes de moi, donc du cursus que j'ai fait. Donc, je m'appelle Sandrine MANSOUTRE, je suis directeur de l'école française du Béton et je suis française. J'ai travaillé pendant par contre 9 ans à l'international. Donc, je suis ingénieure en chimie des matériaux et j'ai un doctorat en physique des matériaux sur la rhéologie des pâtes cimentaires et des bétons. Je suis partie pendant 6 ans au Maroc où j'ai créé une entreprise, une intraprise plus exactement, puisque c'était pour un grand groupe cimentier à Casablanca. Et j'ai pu travailler sur des grands chantiers comme le grand stade de Marrakech, le grand stade d'Agadir et les autoroutes du Maroc sur toute l'adjuvantation des bétons qui allaient sur ces chantiers. Ensuite, je suis partie en Italie, à Bergame, où j'ai pu rayonner sur une zone d'un grand groupe cimentier qui couvrait 8 pays. Et dans les pays, il y avait l'Égypte, le Kazakhstan, la Turquie, la Bulgarie, la Grèce, le Koweït. Il y avait l'île de Chypre également. Et ensuite, en 2011, je suis revenue en France, à Lyon, pour un grand groupe cimentier qui s'appelle Ciment Vica, qui a, sur un poste de direction qualité ciment, donc je rentrais dans les cimenteries, sur 20 sites de production, sur 11 pays, dans 4 continents du monde. Donc de la côte ouest des États-Unis à l'Andhra Pradesh, au sud de l'Inde, en passant encore par le Kazakhstan, le Sénégal, la Turquie, l'Italie, la Suisse, la France, bien sûr. Et donc, autant vous dire que la langue anglaise, pour moi, est utile. Elle est dans mon quotidien. Donc, depuis 1 an et demi, je suis directeur de l'école française du béton, donc j'utilise un peu moins l'anglais, mais du coup, voilà, j'ai cette opportunité de pouvoir vous la mettre à profit. Alors, l'idée, c'était effectivement, est-ce que je vous fais une conférence en anglais? Bon, vous allez m'entendre parler très vite en anglais. J'ai un accent qui va être beaucoup plus simple à comprendre pour vous. Quand vous allez, moi je travaillais en Alabama ou en Andhra Pradesh en Inde, vous allez voir que l'accent est très important. Donc moi, ce qui est important pour moi aujourd'hui, c'est 2 choses. Première, c'est arriver, quand vous allez avoir un flot de paroles qui vont être dites, c'est d'arriver à extraire les informations importantes. Ça, c'est vraiment ce qui est important. Vous n'allez peut-être pas tout comprendre, c'est pas grave. Mais essayez d'accrocher les mots qui vous sont importants. Je pense qu'en plus, vous n'avez pas tous le même niveau. Donc, on va essayer de faire quelque chose qui soit au niveau de chacun. Et ensuite, de ces informations, qu'est-ce que vous en faites? C'est d'arriver également à construire un raisonnement logique dans votre tête. C'est-à-dire, vous allez avoir des informations, et à quoi ces informations vont vous servir. Donc, vous allez voir 2 petits films, puisque les 2 thématiques que votre enseignant a choisies, c'est le béton, sur tout ce qui est formulation, fabrication du ciment, fabrication du béton. On va aller un petit peu sur le chantier. On va décortiquer un peu tout ça. Et en deuxième partie du cours, ce sera l'économie circulaire. Le béton, la filière béton, comment elle s'intègre dans l'économie circulaire. Est-ce que vous voyez l'économie circulaire, ce que c'est? Vous en avez jamais entendu parler? Eh bien, c'est parfait. Vous allez avoir Yves qui va vous expliquer ce que c'est. Alors, Yves, elle est irlandaise. Son accent n'est pas trop fort, ça va. Mais voilà. Alors, on va commencer sur un film qui a été fait par une société d'adjuvants qui est BASF. C'est pas grave, la marque, peu importe, mais j'ai trouvé que ce film était très bien fait parce qu'il va vous permettre de comprendre le processus depuis la fabrication du ciment et vous allez voir tout ce passage jusqu'au chantier. Et il va y avoir un petit plus sur aussi le mécanisme d'action des adjuvants. Je vais vous laisser voir le film, il fait 4 minutes 30, donc c'est moins de 5 minutes. On va le regarder en entier, puis après on va regarder petit morceau par petit morceau sur les 3 premières parties. On ne verra pas après les mécanismes d'action des superplastifiants. La seule chose, vous avez entendu parler déjà de béton, formulation des bétons. Les adjuvants, vous savez ce que c'est. Superplastifiants aussi. Vous savez comment ça se dit en anglais? Superplasticizer. Il y en a autre part. Et ensuite, voilà. D'abord, dans un premier temps, je vais vous dire, posez vos stylos. Vous regardez, c'est tout. Vous regardez, vous n'écrivez rien. D'abord, vous vous imprégnez. C'est pas grave, à la première écoute, vous allez certainement... Beaucoup d'entre vous ne vont pas comprendre grand-chose. Et on va interagir. Mon objectif, c'est que vous arriviez à effectivement prendre les infos et puis à retenir ce qui est important aussi de tout ça, puisque l'objectif aussi, c'est de vous dire finalement ce qui est important dans tous les messages que vous allez entendre.
The feedstocks used for the manufacture of cement are the natural raw materials limestone and clay. These are broken down in crushers into fragments of about 1 kilogram and then ground in a raw mill, together with smaller amounts of iron ore and quartz sand to obtain a fine meal. At the same time, they are dried with the hot kiln exhaust gases from the incineration process. This raw mix is then transferred to a rotary kiln and fired at temperatures of about 1450 degrees Celsius to produce round-like particles measuring about 3 centimeters, known as cement clinker. Sintering is the name used by experts to describe this important process, which needs an enormous amount of energy. In this incineration process, chemical compounds are formed which later cause the cement to harden when mixed with water. After the incineration process, the cement clinker drops out of the kiln and is cooled to about 200 degrees Celsius in a grate cooler. After adding gypsum or anhydrite and sometimes further ground additives like slag, fly ash and limestone, the clinker is ground in mills to produce fine cement. The quantity and type of the additives influence the chemical and physical properties of the cement. The cement is stored in silos and is mostly supplied to concrete manufacturers as bulk material for further processing. Concrete consists mainly of a mixture of cement, water and aggregates such as sand, gravel and crushed rocks. At the concrete manufacturing plant, the cement powder from the storage silo is transferred to the mixer. All the concrete components are weighed exactly before being added to the concrete mixer for a specified time. Finally, the chemical that mixtures like the superplasticizer glenium is added. In this process, the cement waterette mixture slurry becomes the glue, also known as cement paste, that holds the aggregates together. The fresh concrete mass then flows into mixer vehicles to be transported to the construction site. The properties of concrete can be specifically varied by using different mixture proportions and admixtures. The admixture glenium, for example, increases the flowability of the concrete so that the densely packed steel reinforcement bars of a foundation can be coated quickly and completely with concrete within a short time. A pilot plant comparative study between conventional concrete and concrete with added glenium, but with the same water content and mixing ratio, clearly shows. With conventional concrete, the flow process already stops after 5 seconds and after a distance of about 25 centimeters. Concrete to which the superplasticizer glenium was added flows much faster, and the distance travelled over the same period is about 65 centimeters. Modern superplasticizers like Glinium are based on synthetic organic polymers such as polycarboxylate ether, called PCE for short. A PCE molecule consists of one long main chain and shorter side chains. The main chains are negatively charged. When cement is mixed with water, it reacts and starts to form crystalline needles that interlock with each other to form a hard, rock-like substance. When the PCE molecules are mixed with liquid concrete, they are absorbed onto the surfaces of the particles contained in the concrete. The side chains of the molecules point outwards, like the spines of a chestnut burr, and hold the particles at a distance to each other. This makes it easier for them to move against each other, and the concrete becomes more fluid. Concrete can be given the desired properties by varying the length of the main and side chains. BASF, the chemical company.
Yes, I think it's a very nice movie. In just 5 minutes, you have the overall view from the starting from the cement production into the concrete, and then you end with the mixture. Have you understood everything? Do I need the microphone? Yes? That's better? So what we will do now, I have cut this movie into five parts. The two last ones we will not take it in detail because I think it would take too much time. So we will take the part 1, part 2 and part 3 for cement production, concrete production, and then on the job site. Is it okay for you? Yes. If I continue in English like this, is it okay for you, or do you want me to switch off? Yes. That's fine? Okay, let's go. So now we will watch again the movie. Then just one part, the part for the cement production. Again, I will ask you to watch it before looking at the question. Then after, you will have the question and you will answer to the question. The questionnaire is about cement production, concrete production, and then the job site. And we will start with cement production. Did you understand all the movie? Who has understood everything? Who is fluent in English? Who is bilingual? No? So we will watch again the first part of the movie, just on the cement production, and then you will read the question. But again, try to focus on the movie first, then we will take the time you need. Don't worry. I would prefer in English, of course. So I would say, if you answer in French, I'm not sure about the interest of this course. But it's better than nothing. I would say, you will have the full note. I don't know about the note, if you're in English. But if you don't know in English, put it in French. But then, we will see after how we can do. But the objective is also that you catch the words in English that are important.
Do your best, please.
But do your best, but you can. So it's...
The feedstocks used for the manufacture of cement are the natural raw materials limestone and clay. These are broken down in crushers into fragments of about 1 kilogram and then ground in a raw mill, together with smaller amounts of iron ore and quartz sand to obtain a fine meal. At the same time, they are dried with the hot kiln exhaust gases from the incineration process. This raw mix is then transferred to a rotary kiln and fired at temperatures of about 1450 degrees Celsius to produce round-like particles measuring about 3 centimeters, known as cement clinker. Sintering is the name used by experts to describe this important process, which needs an enormous amount of energy. In this incineration process, chemical compounds are formed which later cause the cement to harden when mixed with water. After the incineration process, the cement clinker drops out of the kiln and is cooled to about 200 degrees Celsius in a grate cooler. After adding gypsum or anhydrite and sometimes further ground additives like slag, fly ash and limestone, the clinker is ground in mills to produce fine cement. The quantity and type of the additives influence the chemical and physical properties of the cement. The cement is stored in silos and is mostly supplied to concrete manufacturers as bulk material for further processing.
So, let's start with the first question. What are the two natural materials used for the manufacture of cement? I think, yes. The natural materials, the raw materials. Clay. I think it's also better. Then we will do a little one, on fera un petit à la fin pour la note, mais c'est bien aussi, ça échange comme ça, je trouve.
Oui,
hein, ça vous va? So, clay and clay is argile. And limestone.
Lime.
Something there is not wrong. It's true even, but that was not in the raw materials that we put in the clinker. I've heard about gypsum, and you're right, you're correct. Gypsum is also a natural material used for the cement manufacture. It's, yes, for regulation of the setting of the cement. So these are the words you need to understand and to keep in your mind, the setting of the cement. So gypsum, yes, is used as a regulation for the setting of the cement, but in the clinker, so we are using two raw materials. The main raw materials are limestone and clay. Lime is something else. Who took? So lime, you have hydraulic lime. Lime can be used also on the job sites. What is the name in French of lime? Do you know? No. No. La chaux. Hydraulic lime, la chaux hydraulique. So limestone, there, and clay. With what other compounds the raw materials are ground in the raw mill? This is much more difficult. No. For making the raw materials, you have only limestone and clay. Clay is giving the silica. Limestone is giving calcium. Do you remember? Have you done the chemistry of cement? What other? Silica is from the clay, but we put some more silica in order to be able to burn the clinker in the kiln. There is also some aluminum you need to find. So there are some other materials that are mixed, and something that makes the gray cement, the cement gray color. What is it? In English, do you know? Steel is acid. Iron. Iron oxide is put also in the raw material for making the production of the clinker. So for the raw materials, you can find some iron oxide also, and some additional sand. This is what they say in the movie. Have you heard about this? Core sand, something like this? Core sand is foundry sand. It's the sand we are using in foundry, when they do the molding and of steel. They need some sand, the sable de fonderie, the foundry or core sand. So raw material for cement in the clinker, you say first, the two first. limestone and
Limestone and
clay, and then you add some other compound like iron oxide, iron ore. It is the way you find them in the nature, so it's iron ore. And you can have aluminas coming. Alumina, they don't speak about alumina in the movie, but you can find it as bauxite when you put some bauxite. So this is the alumina. What is the name of the product coming out of the raw mill? Of the raw mill. Of the raw mill. Raw, that means not burned yet. Clinker is after the cooler, so it's after the oven, the furnace, and then the cooler.
Qui n'est pas cuit et cru.
Qui n'est pas cuit et cru. La farine crue, le cru, the raw mill. So you have the raw mill and the raw mill. Be careful when you are talking with English people. They can say the raw mill. Raw mill, c'est le broyeur à cru. And the raw mill, la farine crue. Mill and mill is something very similar, but with the context you can make the difference. What is the heat? The heat in the rotary kiln, 1,000.
1,000.
Say 1,000, not 100, 1,000. 450 degrees Celsius. Be careful if you go to US for working. Raw mill. The raw mill is the tool, and the output
What is a meal in English? MEI. What is a meal?
you may have, but it's also the flour, the meal, say la farine. You do bread with meal and flour. So the raw meal, and it's done in the raw mill. It's the mill, it's moulin aussi. D'ailleurs, même en français, vous allez en Suisse, ils n'appellent pas les broyeurs, ils appellent les moulins. Et d'ailleurs, les moulins chez les meuniers, c'est les broyeurs. So for the temperature, 1,450 degrees Celsius, and if you go to US, we will speak about Kelvin or Fahrenheit, depends. So be careful of the unit you use, and also the tons in US. It's short ton, it's not normal ton, it's not 1,000, it's about, I think, 870 something. So really when you travel and you work in another country, be careful of the unit they are using. You may do sometimes mistakes, just because you did not use the correct unit. So, what are the two other names of clinkerization? So who can explain to me what is clinkerization? What is it? So what is the clinkerization? So first you have a decarbonation, decarbonatation. In English, decarbonation. You don't say decarbonation, huh? Decarbonation. Like hydratation, you say hydration. Sometimes you have a T that is disappearing. So you have first a decarbonation of the limestone, and then there is a so-called sintering in the kiln. Sintering, you use that also for ceramics. En français, c'est le frittage. You have a kind of sintering, so all these different phases are melting together and make another phase. There is also here another name of incineration. So in the movie you use the two names, incineration and sintering. In cement plant you will use more clinkerization. This is more or less the same process. What is the name of the 3 centimeter round particles coming out from the cooler? It's like this. You may have some like this. Out of the cooler. So you have the raw material, they go in the raw mill. Then you have the preheater tower. It's heated in this. It goes into the kiln. And then in the kiln you make a quench, une trempe, a quench, in a cooler. And then you have the, not yet, the clinker. Yes, great. So, there are round particles, more or less round, coming from the cooler. So you have the raw materials that mix in the raw mill, make the raw mill, and the clinker. What is the property of cement to react with and under water? So the fact that it's making the setting, the prise. So what is the property? 200 years ago, an engineer called Ricard made a discovery, a scientific discovery. He put the theory of hydraulicity. Have you heard about hydraulic? Hydraulic lime, hydraulic something, we just talk about hydraulic lime. So the property of making the setting with and underwater is hydraulicity. So cement is an hydraulic binder. Do you know what is a binder? To bind. To bind something with. Un liant. A binder is something qui lie, qui fait la liaison. Un liant. Hydraulic binders is un liant hydraulique. And do you know what is the main constituent responsible for this property of being hydraulic binder? What is the main component who makes this property? If you take a stone and you grind it, is it hydraulic? What in the cement? So what is in the composition of the cement? You said no more the raw materials. There is something that we will grind. What have we produced here in the kiln? In the kiln, limestone clinker. Limestone is the raw material. You have transformed this raw material in order to make something hydraulic. This hydraulic material is the clinker. That is why you put these materials with some specific chemical proportion into the kiln. If you did not make that, you could take some limestone and clay together, mix it, and you put water. You will never have a setting. You need to go through the kiln. And the kiln produces the clinker. This clinker will be ground with gypsum and some other stuff if we need. And then you have the cement. Is it clear for you? You take the limestone and the clay. Natural material. You mix them together, you crush and grind in the fine material, which is called the raw meal, la farine crue, because it's not cooked yet, it's not burned. This raw meal will go into the kiln, in the rotary kiln. We will watch the movie again, so then you will see in the rotary kiln at very high temperature, 1450 degrees. This makes a reaction which is called the sintering or clinkerization. Something happens, the molecules come together and make from limestone and clay something that is mixed with C3S, C2S and all this chemistry of the cement, and it gives something called the clinker. This clinker will be ground after again in another mill, no more the raw mill but the cement mill, with gypsum for regulation of the setting, and this will give the cement. And the cement, when you will put water in the concrete with the admixture and the aggregate. It will make concrete. Can you see? You follow me now in the process? So two important things here are the vocabulary, but also the process to understand what happens in the cement, how you make something that make a glue after ça va faire une colle. It's something extraordinary coming from two stones you take from the nature and you make it glue. So what is the basic composition of Portland cement? We have just talked about it. You have Portland clinker and gypsum. Gypsum. It's a calcium sulfate. You may have three types of gypsum called gypsum, hemihydrate or anhydrite, depending on the quantity of water you can have. Gypsum is also what makes the plaster. Hein? Le plâtre, c'est un gypse déshydraté. On remet de l'eau, ça refait du gypse. C'est le plâtre. That is plaster with gypsum. But then in the cement, Portland cement, we have clinker and gypsum. Clinker plus gypsum. Do you know the difference between Portland cement and blended cement? What is blend? Blended cement. Blend, ça veut dire mélanger. Un mélange. Si vous... C'est pas un bon exemple, mais dans les whisky, par exemple, vous avez des pure malt et des blends. Blend, ça veut dire des mélanges. Des assemblages.
Et dans votre cuisine, vous avez un mix qui s'appelle un blend.
Donc un blend, c'est un assemblage. Parce que c'est pas un mélange qui est fait n'importe comment. It's a very specific, with specific proportion for making a special blend. And we have also that in the cement. So clinker gypsum, that is Portland cement, pure cement. But then, in order to reduce or to reduce the CO2 footprint, environmental footprint, we reduce this by reducing the clinker in the cement. Because you have seen that clinker has to be burnt at high temperature, but you need it, because this is what gives you the hydraulic properties. But in order to decrease the footprint, we can add some other additives. What are the three common additives we find in blended cement? Great. Fantastic.
Slime.
Yes. Wow. I'm impressed. You may have limestone also. So I will say 4. Limestone, you're right. They don't speak about that in the movie, but you're probably... Starting with a P. Puzzolana. These are the 4 main constituents added as an additive in the cement. So blended cement can be a mixture between clinker with limestone, fly ash or slag or puzzolana and gypsum. Don't forget the gypsum. And you can also mix and make blend with 2 of these. And fly ash, it's called in French cendre volante. Elles volent. Elles sont issues de l'industrie, en fait des centrales thermiques. Quand on brûle le charbon, il y a des cendres. These ashes has a lot of silica. And slag, it's derivative product from the steel industry. C'est les hauts fourneaux. Et le laitier est issu, en fait, c'est un sous-produit, un déchet de l'industrie de l'acier. Puzzolana. Puzzolana, you have some in the center of France, the volcano, and there is a lot in Italy. These 3 fly ash, slag, and pozzolana, maybe most fly ash and pozzolana gives pozzolanic effect, reaction with the Portlandite. Have you seen that? Pozzolanic effect? You may have some Portlandite, CaOH2, la portlandite en français, Portlandite in English. So Portlandite is making the reaction with the silica from fly ashes and pozzolana and increases the long-term strength. So now you can watch the movie again, and then we will see the results again. Is it clear for you? We will watch first the answers, and then you will watch the movie again, and you will understand it better. So, limestone and clay for the two natural materials. Iron ore and core sand, or foundry sand, but in the movie it's core sand. The output of the raw mill is the raw mill. The material is fired up at 1,450. That is maybe not this one, the exam. Clinkerization is also called incineration and sintering. The round particles are clinker, hydraulic property for the reaction of being able to set under water. The hydraulic property is mainly given by the clinker. Main constituent of Portland cement are clinker and gypsum. And then the three most common compounds, additives that can be found in blend cement are slag, fly ash, and pozzolana, and limestone. And this is referring to the NFEN 197/1 standard. I forgot to tell you, I'm also head of the French delegation to the Commission, European Commission for Normalization Standards of Cement. So in 2 weeks I will be in Dublin with some other European countries in order to make the new standard. And in few months, before the end of the year, you will see new cement, CEM 6 and CEM 2C. I can tell you that now, so it will be at the end of the year.
The feedstocks used for the manufacture of cement are the natural raw materials limestone and clay. These are broken down in crushers into fragments of about 1 kilogram and then ground in a raw mill, together with smaller amounts of iron ore and quartz sand to obtain a fine meal. At the same time, they are dried with the hot kiln exhaust gases from the incineration process. This raw mix is then transferred to a rotary kiln and fired at temperatures of about 1,450 degrees Celsius to produce round-like particles measuring about 3 centimeters, known as cement clinker. Sintering is the name used by experts to describe this important process, which needs an enormous amount of energy. In this incineration process, chemical compounds are formed which later cause the cement to harden when mixed with water. After the incineration process, the cement clinker drops out of the kiln and is cooled to about 200 degrees Celsius in a grate cooler. After adding gypsum or anhydrite and sometimes further ground additives like slag, fly ash and limestone, the clinker is ground in mills to produce fine cement. The quantity and type of the additives influence the chemical and physical properties of the cement. The cement is stored in silos and is mostly supplied to concrete manufacturers as bulk material for further processing.
Are you ready to go on the concrete plant now? The batching plant? Concrete batching plant, ready-mix concrete, aggregates. Let's see all this.
Concrete consists mainly of a mixture of cement, water and aggregates such as sand, gravel and crushed rocks. At the concrete manufacturing plant, the cement powder from the storage silo is transferred to the mixer. All the concrete components are weighed exactly before being added to the concrete mixer for a specified time. Finally, the chemical that mixtures like the superplasticizer glenium is added. In this process, the cement-water admixture slurry becomes the glue, also known as cement paste, that holds the aggregates together. The fresh concrete mass then flows into mixer vehicles to be transported to the construction site.
Do you want to start to answer the question, or do you want to watch again the movie, The Part of Concrete? Again?
Concrete consists mainly of a mixture of cement, water and aggregates such as sand, gravel and crushed rocks. At the concrete manufacturing plant, the cement powder from the storage silo is transferred to the mixer. All the concrete components are weighed exactly before being added to the concrete mixer for a specified time. Finally, the chemical that mixtures like the superplasticizer glenium is added. In this process, the cement-water mixture slurry becomes the glue, also known as cement paste, that holds the aggregates together. The fresh concrete mass then flows into mixer vehicles to be transported to the construction site.
What are the three materials considered as aggregates? I have the three. I would just add a fourth one that is not, but thank you. Gravel, sand, and rocks. Trash rocks. Thank you. Great. Again, there is a fourth one that is not as aggregate. That is not in this movie. And we will talk. Thank you. Thank you, madam. I wanted to speak about recycled concrete. Very good. We will talk about this after with the circular economy. Reusing what has been debuilt, deconstruction or demolished, into the concrete again. And that will be another kind of aggregate called recycled concrete. Thank you. The components added, so that is Agnès who could speak about this better than me because it's her job, making concrete, ready-mix concrete. Components added to the cement in the mixer are weighted exactly before, during, or after being into the concrete. Before. Thank you. It's very important because if it would be after, you cannot correct. So everything, and if you have you seen a batching plant already? Concrete batching plant? Have you been there? No. So everything is scaled very carefully in order to know what exactly you put in the concrete. Huh? What is the mixing time? The mixing time, not the admixture. The mixing time of the concrete in the mixer. Do you know how long we mix? I will give you some example of time. In a kiln, for making the cement, this clinker stays about 30 minutes to 40 minutes in the kiln. In a cement mill, depending if it is vertical or horizontal, can be a few minutes. The concrete is something has to be very, very quick. So the time, there is no exact time. That is the trick. The trick. You understand the trick? Okay? Because it's always specified. It depends on your concrete. But more or less, it's about 1 minute, 1 minute 30 seconds. Even if you want to add some second, it must be a very special concrete. Because every second you will add will cost a lot of money. So, you see a truck, mixer truck? Do you know what is the size of these trucks? How many cubic meters of concrete? It goes from 6 to 10 cubic meters, more or less, 8. One mixer, normal mixer in the batching plant is about 1 cubic meter, more or less. You may have 2, but imagine each mixer is 1 cubic meter. You need to fill up 8 cubic meters concrete track. That means about 10 minutes if you want to fill all. And then every 10 minutes you need to make the truck going on the job site. So it's between 10 and 15 minutes. I don't know about each truck. When is the superplasticizer? So you have heard about Glenium. Glenium is the brand I told you at the beginning, just remain superplasticizer. It's the new generation superplasticizer. The last part, they talk about polycarboxylate. You have linosulfonate, polynaphthalene sulfonate. These are the superplasticizer from old generation, and the new generation is all these polycarboxylate superplasticizer. Glenium is a brand, but when do you put the superplasticizer ideally in the mixture? It's not what is done normally. It's not done all the time, but ideally it is
Finally.
at the end. Do you know why it's better to put the superplasticizer at the end? Pourquoi on met le superplastifiant à la fin? Je vais vous le redire en français parce que c'est important que vous compreniez pourquoi. Le superplastifiant, on va voir à quoi il sert. Il sert à quoi?
Pour améliorer l'ouvrabilité.
Exactement. Donc si on met d'abord l'eau dans le béton, les granulats, ils ont toujours un peu d'absorption. Donc ils vont absorber une partie de l'eau. Et une fois seulement que ces granulats auront absorbé toute l'eau qui sera en plus sera utilisée pour la maniabilité. Si vous mettez votre superplastifiant dans l'eau dès le départ, les granulats ils vont absorber et l'eau et les superplastifiants, les molécules qui sont là. Et du coup elles seront à l'intérieur des granulats, elles ne serviront à rien. Donc vous allez devoir en mettre plus pour avoir le même effet. Si vous mettez d'abord de l'eau, vous attendez les granulats s'absorbent, et après vous mettez le superplastifiant dans l'eau finale, tout ce que vous aurez mis sera utilisé pour disperser les particules de ciment et donc la maniabilité. Voilà, en fait c'est...
Qu'est-ce que vous entendez par l'eau finale?
Alors l'eau finale, idéalement, vous mettez l'eau en 2 fois. C'est ce qui se fait en préfa. En béton prêt à l'emploi, c'est plus difficile parce que c'est une installation un petit peu plus... Donc ce qu'ils font, c'est qu'ils divisent l'eau en 2. Ils font d'abord venir de l'eau, la moitié de l'eau toute seule, et après, d'une autre pompe, la deuxième moitié à la suite, avec l'adjuvant.
Il n'y a pas moyen de faire plus de plastifiant avec le reçuel comme on sert.
Alors, normalement, vous ne devez pas avoir de reçuage. Si vous dosez bien ce qu'il faut, vous n'avez pas de reçuage. Si vous faites un bon béton, vous ne devez pas avoir de reçuage. Toujours, il y a une légère détente, c'est pas vraiment du reçuage. Mais ça changera pas grand-chose, puisqu'en fait, vous le saurez, ce qui peut se faire, c'est que, du coup, si vous allez mettre plus de superplastifiant, si vous faites, ça va vous coûter plus cher. C'est pour ça qu'en préfa, alors, sur chantier, généralement, en plus, vous utilisez du béton prêt à l'emploi qui arrive de centrale à béton. Et en centrale à béton, très souvent, ils ont une seule pompe à adjuvant et une seule pompe eau. Donc mais en préfa, où ils ont les moyens de faire des choses un petit peu plus minutées, parce qu'ils n'ont pas beaucoup de formulations différentes, ou en tout cas, c'est contrôlé. Vous faites votre béton sur chantier, déjà? À la bétonnière? Et vous utilisez du superplastifiant? Eh bien, mettez-le à la fin. Vous verrez la différence. Enfin, quand vous ferez des essais, hein, pas quand vous serez en train de faire un chantier, mais un jour, faites la différence. Faites votre béton une fois, vous pouvez faire ça en labo. Hein, vous mettez dans l'eau de gâchage votre superplastifiant, puis après, vous faites la même chose. Vous mettez la moitié de l'eau, vous mélangez la deuxième moitié avec le superplastifiant. Vous faites votre code d'Abrams et vous verrez la différence. Il y aura un où votre fluidité, votre maniabilité sera un petit peu meilleure. Alors la question, est-ce qu'il y a des livres pour apprendre les mots techniques d'anglais? Il y en a certainement, mais en même temps, cette commande que m'a faite votre professeur, et ça c'est un petit peu c'est pour vous que je l'ai créé cet exercice, mais qu'après il va être, s'il vous plaît, hein, je le divulguerai à d'autres élèves, parce que si ça vous intéresse de travailler comme ça, je peux constituer aussi un petit glossaire que je mettrai en ligne. Donc il y a une plateforme de ressources béton.com et je pourrais vous le mettre, je le dirai à votre professeur, je vais vous en faire un. Sur tous les mots qu'on a vus aujourd'hui, déjà, What role has the slurry, cement admixture, and water in the concrete? Let's come back. The slurry. What is the slurry? Slurry. With cement you can do concrete, mortar, and slurry. If you have only cement and water, it's a slurry, an admixture, un coulis. Un coulis, ou une pâte de ciment, et un coulis. Slurry, c'est bargotine aussi. C'est aussi d'ailleurs le mot bargotine. Slurry, c'est pour tout, par exemple, les coulis d'injection. Slurry. So that is another important word. If you go on consolidation for soils, you will inject some slurry. And what is the role of this slurry in the concrete?
To make it
glue. And what is the common name of the concrete that flows directly to a mixture vehicle? In French, it's béton prêt à l'emploi. In English, I say the word many times in order for you to integrate that. Prêt à l'emploi. Béton prêt à l'emploi. Ready to use. It's really like do it yourself. DIY, but now it's ready mix concrete. And BPE pour béton prêt à l'emploi, RMC for ready mix concrete. So if you see on the document RMC, it means béton prêt à l'emploi, like BPE in French. And what is the name? This word also I repeated sometimes. Of the plant where you produce this kind of ready mix concrete. It's of the plant. Do you know what is a plant?
No.
A factory. A plant is a factory. It's a place where we do things. Une usine. A plant. So where do we do the ready mix concrete? The BPE, it is done in a concrete batching plant. These are words very important if you want to work in the concrete in the future in foreign countries. Ready mix concrete, pour béton prêt à l'emploi, and batching plant is the unit, you also say about unit of production. Plant, unit, batching plant or batching unit. Un batch en français aussi on dit ça. C'est un lot. Quand vous faites des productions par lot ou en continu. A continuous process or a batch process. So concrete is a batch process. You do every time another batch. You empty your mixer, you put again your mix, then you empty. It's a batching plant. What standards? This question you should be able to answer. This is not in the movie. What I call NIM is not in movie. It's additional questions. What is the standard for concrete in France or in Europe? Yes. What is the concrete standard? What is this name? Eurocode is the standard for calculation. NFEN 206/CN. NF because EN 206/CN. Have you heard about this?
Yes.
But now, next time, you should not only have heard about this. This should be immediate. When I ask you what is the standard for the concrete, you should say 206/CN. But now, do you know what is the /CN?
Complément national.
So if you go to Europe, in another country than France, you will have 206, which was the former 1 and 9 for self-compacting concrete, but now he's introducing this standard, so it is now one all standard. Avant, on avait EN 206-1 et 206-9. Ça, c'était les BAP. Maintenant, Tout ça, c'est ensemble. EN 206. /CN, complément national. Because you are in France, and then this goes with this. What is white in the text is all what you will find around Europe. What is in grey square, you have some grey squares on the standard, it's what is in France, the complément national. So we talk about ready-mix concrete. There is another kind of concrete you may find in the industry, which is not ready-mix. Which one? On job sites, you can find two main kind of concrete. One is the ready-mix concrete. The concrete is in a truck, is not finished yet. It comes, it's fresh. You put on the job site, then it hardens, it becomes hard on the job site, and then it's finished. There is another kind of product in concrete you can have that are already hardened. They are already products like blocks, beams, préfabriqués en français, très bien déjà, moitié du chemin, précast. Precast concrete. Et pré-contraint? Pre-stressed. Precast concrete, it's prefab, precast, pre-stressed, pre-contraint. Let's watch again the answers. What are the three main constituents of concrete? Cement, water, and aggregates. The three materials considered as aggregates is sand, gravel, crushed rocks, including also recycled concrete. The components added to the cement in the mixer are weighted exactly before being added into the concrete. The time for mixing the concrete, it is a specified time. No universal time. It depends on several factors, including the mix design, the mixer, the power of the mixer, and so on. The size of the aggregates, many different parameters that will make specification of your time, the time of the mixing. When this superplasticizer is added to the mixture, ideally, at the end, because it reduces the absorption of the superplasticizer with water by the aggregate and increases its performance. The role of the slurry is the glue and the cement paste that binds the aggregates together in the concrete. The name of the concrete that flows directly, so this is the job, the industry of Agnés, is the ready-mix concrete, RMC, and the patching plant is the name of the plant or the unit where we do this concrete. Patching. You need to patch like this for telling, yes, it's not easy to say patching plant. You insist on the patch. And then the end comes easily. The standard is EN 206/CN for the French national complement, and then the precast concrete. We will watch again this part of the movie. Do you want? I want you to watch. It's only 1 minute with all this vocabulary, and then you will understand it better.
Concrete consists mainly of a mixture of cement, water and aggregates such as sand, gravel and crushed rocks. At the concrete manufacturing plant, the cement powder from the storage silo is transferred to the mixer. All the concrete components are weighed exactly before being added to the concrete mixer for a specified time. Finally, the chemical admixtures like the superplasticizer glenium is added. In this process, the cement-water admixture slurry becomes the glue, also known as cement paste, that holds the aggregates together. The fresh concrete mass then flows into mixer vehicles to be transported to the construction site.
I think we will stop now with the cement and concrete because we have only half an hour left. and we will watch the circular economy. Any question about? I just want to highlight this point because we will not have the time to do this question, but this could be maybe a course you could do with your Mr. the Professor. Mixed design, it's important to have this word. Mixed design is the proportion, the mix you are doing on your concrete for a purpose. We talked about blended cement, assemblage. Mixed design is the specific proportion of cement, aggregate, and mixture in order to get one property or several properties. You will often see this mixed design word. Let's go on environment. As you know, concrete is not always seen as environmental friendly. Environment is one focus for the economy, the concrete industry. If we don't focus on our impact on the environment, we will not survive. This is definitely today an industry that is not taking care of its environment will not survive. So it's many years now that the cement factories are making what they can in order to decrease their environmental impact. And then the concrete also is now, since several years again, making the most of what they can do in order to reduce the resources they will use and to reduce as much as they can their impact on the environment. Before we were doing a project from the beginning to the end, and then after the end, we did not know what happened. You just throw in your bin, you were drinking a Coke, your tin, you just throw your tin in the bin. And after that, the bin was going somewhere, and you did not even care about this. But now, even today in your house, you are thinking, what will be the following of the life of your bin, of your tin? Your Coke tin or your telephone. You know that when you will no more use it, it does not disappear like this. There is something. So what is now, instead of a linear economy, we are trying to make a circular economy. That means that after the end of his life, it's not more really the end of his life. You will maybe use it again for something else. So this is how we go into a circular economy, and every industry has to think about this as maximum as they can. And here you will see a movie for the concrete industry, cement and concrete industry, how they are now making their own circular economy also in order to reduce their impact on the environment. This is an Irish movie. You will hear the little Irish accent, but it's not too strong.
Hi, I'm Eve. Have you heard of the circular economy? Well, if you have, good for you. If not, I will try to explain what it is, why it is an important idea, and how the cement and concrete industry help to support the circular economy. The basic idea behind the circular economy is that in nature there is no waste. The whole system cycles the same nutrients over and over again. Like leaves falling from the trees in autumn, those nutrients go back into the soil where they are available to grow new leaves next spring. In the same way, businesses are trying to make their operations more efficient and make their processes more circular by using the same limited resources over and over again. So, instead of making products that get used and thrown away, they're looking at ways to design products and systems to encourage return, recovery, and reuse of the same resources to make new products. To ensure we make the best possible use of resources, the challenge is that we must make products that are durable, that can be repaired or refurbished, reused or recycled. In that way, not only are less resources needed, but consumers are also actively engaged in helping to keep the resources flowing around the system. Let's look at concrete. After water, concrete is the second most used substance on Earth, and like water, it is essential for modern life. Can you imagine the world without concrete? Even though you may not think about it, we have come to rely on concrete. it is all around us in the built environment. Concrete fulfills many of the requirements of the circular economy. It is manufactured from local materials. It is durable. Many of the buildings, bridges, dams and tunnels we use today were constructed decades ago using concrete. That is an efficient use of resources. Concrete structures can be repaired and refurbished. Again, an efficient use of resources because with minimal intervention, the life of the building can be extended or it can be adapted for other uses. And eventually, at the end of its life, the concrete in the building can be recycled back into new construction projects. Concrete is 100% recyclable. Cement, one of the key ingredients in concrete, has been playing a significant role in the circular economy for decades. Millions of tons of discarded resources from other industries and from households are recovered and reused in cement kilns each year, both as fuel and raw materials. The advantage of using this waste is that not only are these resources reused, but their use directly reduces the need for fossil fuels and virgin raw materials, and also improves the environmental performance of the industry. Helping to close the loop like this by cycling these valuable resources is exactly what happens in nature, where the reuse of waste from one part of the system benefits the whole system. The cement and concrete industries are vital to maintaining a durable, resilient built environment which supports the circular economy principles. As the global population increases, concrete is one of the key building materials providing the new homes, schools, factories, transport infrastructure, power generation facilities, coastal and flood protection that we need. Shaping the future through clever design with concrete construction will deliver comfortable and secure homes and the infrastructure for the smart cities of the future, while helping to ensure we manage the finite resources of our planet. The circular economy has the potential to really transform business and our way of life by inspiring a new partnership between businesses and consumers, where resources are valued, the needs of our growing population are met, while also improving our stewardship of the earth.
So do you think you are improving your English now? It's easier to understand? When you watch the movie, did you understand the movie? Yes? Just a bit of training. I will give your teacher the link in order to watch again for you the movie. And they are online on YouTube. And it's very important to regularly listen and to practice, to watch these movies. So what is the basic idea of circular economy in nature? To use it again in order to reduce the use of resources. So when you can, you have different choice. Reusing, but before reusing, you can imagine, can you repair? Then can you reuse? And then can you recycle? So in a circular economy, you will see there are several steps. In your mind, you need your telephone. Why do you want to change it? Is it broken? Can you repair it? Or can you use for something else? So with telephone is not really the good example because when they change the software, things like this. But can you use it for something else? And then if you can no more use it, is somebody using it? You can give it. So you can give to another person who will use it. This is what we are doing in cement factories. There are some sub-product waste that are given from other industry and we are using it in our plant. Or you can recycle. That is the different thing. The very end product waste has to be reduced as a maximum. This is the problem of this product. We don't know what to do with. So really try to think to reduce this as a maximum. Can you tell an example in this movie of circular economy in nature? The tree? When the leaves fall down. There is a decomposition on the floor, give nutrients in order to make the new leaves for the spring after. So in autumn and then spring. So it's a bit like this we are doing in our industry. It's not really autumn and spring, but it's a kind of this circular economy. It's like autumn and spring. You reuse what you can. How businesses are trying to make their operation more efficient and making their process more circular? There are two ways of doing. First, I will help you on this. To make their process, this is in the movie, but we don't have a lot of time. First is to make the process the most efficient as possible. This is the very first step. If you have a kiln in a cement plant, you have to make it as much as efficient. You understand efficient? Efficience? Efficace? Performance? So you need first to make your tool, what you are doing, the most efficient. And then the second way you can is to make a substitution of the energy, for instance, you are using on the raw materials with some waste of other industries in order to decrease they say in the movie, the virgin raw material. Les matières premières vierges, dans le sens, l'idée c'est de limiter au maximum ces matières premières qui n'ont jamais été utilisées. Toujours essayer d'utiliser. Instead of doing products that are used and thrown away, what businesses are trying to do? Before recycling. Something that they are not doing in the telephone. Before, you need to have durable. Something durable. If you have something that lasts long, you will have to do less. But the problem today, your generation does not know what is durable.
Yes.
You throw heavy, because it's changing every month, nearly a telephone has to be changed. If you buy, your mother will buy today a washing machine, it will last 1 year, but maybe she had before a 30 years old washing machine and she said, it's 30 years, it was just having no problem. So you have heard about obsolescence programmée. Now they are doing everything except durable. So this is something we have to stop in the future, is to make something durable. First thing, and concrete buildings are durable. You can see in Le Havre, you have very old buildings that are beautiful, and they are nearly 100 years sometimes. So concrete buildings are durable. This is very important. So things is to make durable. If you do it well, it will be durable. Durability of concrete, you have studied that? How to study the durability of concrete. Concrete is not only something that has to be strong the first day, it has to be durable. Durable in some exposition. Les classes d'exposition, c'est important quand vous faites un produit en béton, par exemple, un produit qui tienne le jour où vous le fabriquez, mais qui va durer dans le temps, dans l'ambiance, l'environnement dans lequel vous allez l'exposer. C'est pour ça que vous avez des classes d'exposition dans le N206. Durability, c'est le premier point pour réduire votre impact. Ensuite, after durable, you can repair, and what you said, reuse or recycle. What is the second most used substance on Earth after water? Concrete. It is told in the... So, this is enormous. And we will need more and more concrete in the future. You know that the population is increasing very, very, very quick. Most of you are from North Africa. There are some problems of having people living in houses. So they are building now houses for all this population that is increasing. In European countries, we are old, maturing countries, so there is not a... Excuse me, just a few minutes. We will finish in 10 minutes. So the population is increasing with new incomers, so we need all the time to find new houses. But in India, for instance, or China, they have a real problem of developing quick but smart. Quick but smart. It's important because after war, in France, we have done, or in most of European countries and Occidental countries, we have done quick and sometimes not very smart. So for the future, we have to be sure we do quick and smart the future cities. Question 7. What are the 4 requirements for circular economy that concrete fulfills? We have said, I told about durability. We produce concrete with local material. This is also very important for circular economy to use local material. There is a nonsense to make some product coming from abroad, whatever the country, and to make kilometers and kilometers in order to make construction material. Concrete is done with the aggregate, with the cement, the water that is locally produced. It's repairable, we can repair, and then we say it is 100% recyclable. These 4 points are very important for concrete in the circular economy. How cement industry is active in the circular economy? How? What do they do? We have told about this before. They take some element factory, that means some waste from other factories, and they put as a substitution either in the fuels for energy or in the raw materials. And then they use again and again. The recycled concrete can be used as an aggregate in the concrete, but it also can be used in the cement. 2 years ago, we have done, there is a projet national called Béton. I don't know if you heard about it. It's a national project where 50 partners in France are working together. And 2 years ago, there was a production of clinker done with 15% of substitution with concrete, with recycled concrete. Donc, en matière première, il y a eu 15% de béton recyclé qui a été mis dans le raw meal, la farine crue, pour faire du clinker. Maintenant, tout ce process-là, vous le connaissez. Donc, dans ce procédé où on prend l'argile de calcaire, on broie finement pour cuire, et ben, il y a eu 15% qui a été substitué par du béton recyclé de déconstruction. And the clinker has been produced like this. So this is a real circular economy. And what is the name commonly used for the city of the future? I just said quick and smart. So it's, you've heard about the smart cities. Have you heard about the smart cities? Les villes intelligentes? The smart cities? No? That is the future. We are talking about smart cities everywhere. So, how to make your city smart? Again, quick and smart. It's important for comfort, environment, everything. I think everywhere, you know, in France, we are talking about, in Paris, for instance, the Grand Paris. Grand Paris has to be thought as a smart city. In Morocco, they are developing some satellite cities. Or in India, they have a project of 100 cities, new cities, 100, you can imagine, 100 new cities coming from nowhere. I don't know if you know Kazakhstan. Kazakhstan, you have one, Astana is the Kazakhstan capital. I've been to Astana about 20 or 15 years ago. It was nothing. Today, you know Dubai? It's even bigger than Dubai. It's just enormous. So this is, if you look online, Astana, Kazakhstan in French, you will see this is a smart city, grown from nothing and just has to be, has been thought with smart grids Smart grid, c'est tous les réseaux intelligents qu'on va faire. So this is the future of the development of territories and cities, is the smart cities. Let's watch the movie again.
Hi, I'm Eve. Have you heard of the circular economy? Well, if you have, good for you. If not, I will try to explain what it is, why it is an important idea, and how the cement and concrete industry help to support the circular economy. The basic idea behind the circular economy is that in nature there is no waste. The whole system cycles the same nutrients over and over again. Like leaves falling from the trees in autumn, those nutrients go back into the soil where they are available to grow new leaves next spring. In the same way, businesses are trying to make their operations more efficient and make their processes more circular by using the same limited resources over and over again. So, instead of making products that get used and thrown away, they're looking at ways to design products and systems to encourage return, recovery, and reuse of the same resources to make new products. To ensure we make the best possible use of resources, the challenge is that we must make products that are durable, that can be repaired or refurbished, reused or recycled. In that way, not only are less resources needed, but consumers are also actively engaged in helping to keep the resources flowing around the system. Let's look at concrete. After water, concrete is the second most used substance on Earth, and like water, it is essential for modern life. Can you imagine the world without concrete? Even though you may not think about it, we have come to rely on concrete. It is all around us in the built environment. Concrete fulfills many of the requirements of the circular economy. It is manufactured from local materials. It is durable. Many of the buildings, bridges, dams and tunnels we use today were constructed decades ago using concrete. That is an efficient use of resources. Concrete structures can be repaired and refurbished. Again, an efficient use of resources because with minimal intervention, the life of the building can be extended or it can be adapted for other uses. And eventually, at the end of its life, the concrete in the building can be recycled back into new construction projects. Concrete is 100% recyclable. Cement, one of the key ingredients in concrete, has been playing a significant role in the circular economy for decades. Millions of tons of discarded resources from other industries and from households are recovered and reused in cement kilns each year, both as fuel and raw materials. The advantage of using this waste is that not only are these resources reused, but their use directly reduces the need for fossil fuels and virgin raw materials, and also improves the environmental performance of the industry. Helping to close the loop like this by cycling these valuable resources is exactly what happens in nature, where the reuse of waste from one part of the system benefits the whole system. The cement and concrete industries are vital to maintaining a durable, resilient built environment which supports the circular economy principles. As the global population increases, concrete is one of the key building materials providing the new homes, schools, factories, transport infrastructure, power generation facilities, coastal and flood protection that we need. Shaping the future through clever design with concrete construction will deliver comfortable and secure homes and the infrastructure for the smart cities of the future, while helping to ensure we manage the finite resources of our planet. The circular economy has the potential to really transform business and our way of life by inspiring a new partnership between businesses and consumers, where resources are valued, the needs of our growing population are met, while also improving our stewardship of the earth.
Voilà.